Let's take a look at this kinematics question with exponential function. This question is about a fire truck, where its displacement as meters from fixed point O is given by this exponential function. I want to find the time where P is at instantaneous rest. So what is so special about instantaneous rest? It is when velocity equals to 0. But do we have velocity here? They only give us displacement. How can we find velocity from my displacement? I will need to do differentiation. Differentiate my displacement to get velocity. Note how I can actually take out the scalar constant 200 and just differentiate the exponential function. By differentiation, we will get 200 and I'll differentiate e power negative 2t, bring down power, which will be negative 2, and keep the function. Bring down power and I will keep my function. So this is my velocity function. Let v equals to 0 in order to find the time at instantaneous rest. When I divide by 200, it will leave me the exponential function like this. To solve for exponential functions like this, I will need to bring one function to the other side. Let's bring negative 2 e power negative 2t to the other side and I'll get this. Now the trick here is to divide by exponential function e power negative 2t. And I will also divide by 3 to get this. Now, division of the same base, I will subtract my powers. Answer is e power negative t on the left hand side. Let's convert it back to ln form, where I get negative t is ln 2 over 3, and I'll get my value of t. The answer for time is 0.405 seconds, but very important thing to take note is that at this timing, since my particle is at instantaneous rest, it means it can change direction. So for future questions, I need to take note of this very special timing. Now let's come to part 2, where I want to find the total distance traveled by P during the first 3 seconds. And take note as what we mentioned, my timing 0.405 seconds is the time where particle is at instantaneous rest, which means it can change direction. So there are 3 timings that we need to take note. These are my 3 timings. T equals to 0 would be the initial timing where it first started. T equals to 3 would be the final timing. And 0.405 will be the time where particle is at rest. At each of the timing, I will need to find my displacement S. And to find it is very simple. Just sub T into my displacement. I will get all these displacements. 0, 29.62962, and 0.47106. So now let's calculate the total distance traveled. We will take the difference in the distance at each of the timings to get our answer. So our answer will be 58.78 in 4SF, where we'll round off to 3SF, 58.8 meters. And that's the end of the question.